All right, welcome and thank you to everyone joining us for the Water Connections webinar, our first webinar in a webinar series. It's a restart, though, for a lot of us, right, who have been solid attendees of our webinars in the past. The Water Connections is really a new start from the standpoint of we've been doing these webinars now for about 4 years, or a little over 4 years now, and we took a pause. We went out to a lot of our viewers and said, what is it that you wanted to see? What did you like? And we're coming back now with the Water Connections webinar as what we think is going to fit all of your interests even better than we have in the past. Now, we will be talking about all things water, and it will include irrigation, conservation, sustainability, gardening, agriculture. We're going to hit the full gamut of subjects, and I think you're really going to like it. And one thing's for sure is I know you're going to like today's conversation because we've got the CEO of Orbit, Stuart Eyring, here today to talk about water conservation. Now, Stuart's been in this industry for over 18 years. He's got an MBA from Wharton, and if you've watched any of his content on LinkedIn, you know he's very creative. And one of the things I think is interesting is, as you know, Stuart's very bright. He also has this creative side and technical side that you just don't find in the industry. He's one of my favorite people in the industry. I'm so excited to talk to him about water conservation today. Stuart, welcome, and thank you for joining us today.
Thank you, Richard. Great to be here.
Yeah, so Stuart, I was looking at your signature the other day, and you've got a lot of letters behind that signature, a lot of certifications in irrigation. Can you tell us a little bit about what they are, what they mean, and why they're important?
Yeah, the certifications are something that when I first came into the industry in 2005, it was a way for me to understand the industry better. I know many, and I'm sure many on this webinar today have been in the industry for so long that all of the facts, the data, the processes are second nature. For me, it was new in 2005, and the certifications were a great way for me to get up to speed. Started with certified landscape irrigation auditor, and just went on from there. And kind of what I'd say the benefit of them is it allows you to see irrigation and water usage really across the full spectrum. Think of like certified landscape water manager and ag water manager really is in the scoping phase where the focus is of project planning. And then you've got the CID, certified irrigation designer, contractor, technician, really in the execution side of it. And then you've got the landscape irrigation auditor, Gulf irrigation auditor, and they're really in the validation part of it. Did we do a good job in the design? And then on an ongoing basis, is that good? And then for the ag side, there's the certified ag irrigation specialist, and that really covers the gamut of ag, certainly on a general level. And so I super appreciate those certifications just for enabling me to get up to speed faster on things that I think most of you already knew, but I needed to figure out the industry. So super appreciative of the overall education and the certifications.
Yeah, so these certifications come from where now?
They are from the Irrigation Association. And it's a large body that really covers all aspects of irrigation and water management. And you and I, both know the Irrigation Association well from participation, but we've also had an opportunity, both of us, to serve on the board in the past.
Yeah, and I know you've been very supportive of the Irrigation Association, their certifications, and this month is actually Smart Irrigation Month, right?
Yes, it is. July.
So so we are celebrating that all month long. And Stuart, they do this right because this is the month in which we use most of the irrigation water. Typically, not just irrigation water, but it's the highest use month for water. Trying again to bring some awareness to this, right, and support a conservation message.
Yeah. To all of you joining us from the Southern Hemisphere, we recognize that July is not the peak month.
That's right. Okay, thank you. So, today you're going to find that most of our audience is, we're preaching to the choir, right, about water conservation. But I just wonder, in preaching to the choir, why it becomes important for us to give a good message of conservation. Why? How does this help us? What in the world does, can we hope for as a result of this?
Well, that's a great question. I think that just generally, we're all aware of the importance of water, particularly fresh water, and how limited it is. Certainly, you look at it, what its distribution is, and I'll use rough, but I think fairly accurate numbers is that 96.5% of water is saltwater in oceans. And then you've got another, about 1.7% that's in the glaciers and permanent snow. And that leaves about 1.7, percent of the water in the world that then we have available. And much of that is not close to us. It's in parts of the world that don't have large population. And so the population centers just have significant stress when it comes to water supply. In many cases, near those population centers, there's not really the opportunity to create more supply. And so, of course, then the focus on conservation, allowing us to continue as a society to grow. And I think that, growth is something that we have to accept. Obviously, we look for positive GDP in economies. We know when that goes negative, that's bad for a country, bad for states and cities. And so growth is a necessary part of the equation in our society. And with limitations on water, conservation is critical. I would just also add that, just interestingly, while there's a lot of water in the air on a percentage basis, it's like super small. It's in the thousandths of percent, and yet it's so consequential in driving everything that has to do with plant water usage. It's a super important factor, but the reality is there's not that much actual water in the atmosphere.
Yeah, I think that's really surprising too. I know that certainly when I'm out and about talking to people about water conservation, one of the questions I always ask is, where did your water come from? And I'm always amazed, or I used to be amazed. I'm not anymore, that people don't really have a handle on where their water comes from, how much it costs, or how much they use. But what they do know, and this is true for 99% of us in the US, really 98%, that every time I turn on the faucet, water comes out, and it comes out, and it's relatively inexpensive. Now, that's one of the challenges of conservation, right? Is I say it's relatively inexpensive, but what I use today, I really don't find out how much I use for a couple months, because I'm on an every other month bill, and then it takes a month to get your bill. And so as a result, I can't say, gee, my bill's going up, and so I want to change my habits today. It's been 90 days since I had those habits. But so I think there's a little challenge in that reporting. But even if it's being reported, sort of have a sense that some people say, well, if I can get others to conserve, then I won't have to conserve. So what are your thoughts on that?
Well, my thoughts from the many LinkedIn posts and the videos I do associated with those posts is that I'd like there to be more awareness. I know that from my own dinner table, as I talk about the scarcity of water at home, at least in initial conversations, as I was really getting more attuned to water conservation. The folks at my dinner table would say, well, it falls from the sky and it's nearly free. And it gives the perception that perhaps conservation isn't as important as we know it actually is. And the interesting situation we see in places like California, where we look at Owens Lake, is the result of what happens when there is no water at the end. And Richard, you and I have had conversations in the past about what's called the tragedy of the commons. And there's Garrett Hardin back in the late 60s put out this idea, not necessarily original, but did it in an interesting way, just to say that when people share a resource and then somebody overuses the resource, that it has negative impact on everyone else. And love the graphic here. It's Rapa Nui Easter Island. And of course, that's a place that was once treed, had trees, and then reached a point where there was no tree. And so the question is asked, what was the person thinking who cut down that last tree? And what we know about scarcity is that probably there was such a rush to cut down that last tree that probably wasn't just a single tree being cut down, but that simultaneously the combination of certainly some factors of climate change, but important at the time, but then importantly too, the scarcity and people taking more, and the tragedy of the commons. And tragedy being, I think, as Socrates defined it, is the combination of pity and fear, right? When you're sitting there realizing that you're at the last one. And certainly with water, I'm glad we're having this conversation. And I'm grateful for water conservation managers at conservancy districts, at utilities, who have actually a tough role. I mean, most water conservancy districts and utilities are in the business of delivering water. There's a charge for it. They have budgets to meet. Water conservation is something that, as I mentioned at the outset, allows for continued growth. But it's not always the kind of thing that it's not necessarily beneficial if all the water is saved immediately, because there are budgets to meet, and that water needs to be sold. But that message on where are we with regard to supply and demand, and that I will say drum being beat is really important, so that we don't experience in our cities or even in a rural environment a tragedy of the commons, where we realize that we're fighting over the last remaining gallons of water. And so certainly what we're doing here is having a proactive conversation of saying, what can we do to ensure that wherever we are, and recognizing that situations can be very different parts of the world, different climate patterns, but that we don't end up in a result where we find that demand has far exceeded supply and drained supply.
Yeah, so it's interesting, Stuart, because I was thinking about this. I traveled to a conference that I was speaking at a few months ago, and my Uber driver, of course, asked me where I was going, what I was doing, and I told him I was going to speak about water conservation. And his comment to me was, is that really a thing? Are we actually going to ever run out of water? He was very much in disbelief, right? And for all of us who turn on the faucet and water comes out every day, we're not that concerned. I don't think the general public is. What are your thoughts on that? Could we actually run out someday? Could you imagine that?
Well, Richard, you and I were at dinner recently with Monty Teeter and talking about the Ogallala aquifer that he's on in Kansas. I think he's western Kansas, where that's a finite reservoir or aquifer, I should say, and created millennia ago, that does not recharge normally in today's environment. And so, yeah, there are many people who actually are on finite aquifers and are watching the drawdown, with an end, coming at some point to that source of water. So I don't think this is some theoretical conversation. And certainly there are other places where we are here in Salt Lake City, the discussion of withdrawals, so diversions and depletions relative to the water that makes it to the wetlands in the Great Salt Lake. And the fact that as we see increased surface temperatures, higher plant evapotranspiration, that it puts pressure on supply, and demand definitely has to change. So I don't think in any way that what we're talking about here is theoretical or hypothetical to most people in the world.
Yeah, and certainly I think for those viewers who have traveled the world, right? You've definitely traveled to places where water is a lot harder to get, that it's not available 24/7, and it's a little tricky with the water you're going to get. So I think a lot of us have experienced that and have that concern now. I certainly believe, and I just want to remind everybody too that we do have the Q&A open now, and I'll be monitoring that for your questions. If you have some, please put those in there, and we'll be sure to get them addressed here on the webinar. Now, somebody did have a question about technology, Stuart, and they want to know, is the water situation something that can be solved with technology?
I appreciate that question because it's Richard, you and I spend most of our time answering this. The answer is absolutely yes. And the technology really is designed to do there are three areas that we have to focus on, right? One is timing. Technology, big assistant in the timing of when we apply water and how much water we apply, the precision with which that water is applied. And then there's also this part that is as much then of a discussion, certainly could be a technology aspect of it, but it's the selection of plants and crops that are most ideal to achieve the goal, the scoping goal for a landscape or a farm in the area that it is. And just specifically what we're looking at here from a technology standpoint, this center pivot happens to be in Enterprise, Utah. And it's to me, it's really interesting because it captures all three elements of timing, precision application, and crop selection. So this happens to be controlled by a smart irrigation controller, and it's one of ours. And so to be a little bit brand specific here, this happens to be a Beehive center pivot controller. And then you can see that the drops on this center pivot are the drops then are very close to the ground, with then very specific nozzles on them that in this particular area address the fact that it's super windy. In fact, the joke in this part of the world is that they were pioneering and they were headed to California. They got to this part of Utah. The wind was blowing so hard that they just circled the wagons. And then they agreed that they would leave as soon as the wind stopped blowing. And 150 years later, they're still here. So I think that's a little bit of a special situation, but it's one of where the lower that you can get that water with the more specific nozzle and then droplet pattern to it, the higher the efficiency is on it. So that's precision. And then the crop, for those who really know crops, this is triticale, which is a specific kind of hay, alternative to alfalfa and traditional alfalfa. And in this case, in this particular farm, they actually did something that was really unique. And if you don't, Richard, or would you mind if I?
No, I think this is really fascinating. I've got some
right.
follow-up questions too on this. So
yeah, so what was really unique here is that this particular farm operation, the head of it is just super proactive from a technology standpoint, and evaluating the technology against the water rights that they had and their predominant water right. They've bought up a lot of additional farmland across this valley and brought these together into a single operation. But the predominant water right has been a 48-inch water right, so 4 acre-foot water right per year. And just looking at the combination of technology and crop options, really came up with an innovative idea that he approached the state with, which allowed them to, in exchange for reducing down the amount of water that they use from 48 inches down to 38 inches, I think it was a 10-inch adjustment and a give up, that then allowed them to flex their water across additional acreages. So they were able to put more land under cultivation with that then same 38 inches of water applied to that was applied against the initial acreage could be applied against the expanded acreage. And then with the more precision technology, they actually then with less water they've increased productivity and yield in the operation. And so I think this is a great example. It's very ag centric, and for those who focus more on landscapes, it may not seem as relevant, but it really highlights how technology can be used to get actually more beneficial use of that water, with actually then using less of the water overall, which then frees it up to, then part of that water has been used to convert over to M&I usage. And so really it's a win-win. So anyway, that's an example of technology being applied in timing, precision, and crop selection that I think represents a helpful example for what could happen elsewhere.
Yeah. Now your company has a product, Beehive controllers, that work on center pivots, right? And kind of the thing I like about this concept is I believe it's putting some older center pivots working much more efficiently. So we're getting more time, more use out of these center pivots. But what else does your product do to help?
Yeah, so in this particular ag case, you're right. I mean, it's designed so that the three major brands of pivots, as well as some national pivots, it's a simple wiring harness change, but the technology is a global technology. And in fact, Brazil is one of our largest markets for this. But of course, we have applications for that extend to commercial landscape. And of course, Richard, you and I work together, specifically with the ET Water technology there. And then of course, on the Beehive side, commercial space, but then also down into residential. And residential, not just being in full automatic system irrigation on permanently installed in-ground irrigation, but then also on a hose as well. And I'll just highlight that hoses is super important. That while the volume of any zone within hose tends to be smaller, when you sort of think of, and let's just take the U.S. as a reference, but if you kind of think of nominally 70 million plus, and it's certainly plus at this point, single family detached homes, and then think of at least one, probably two hose bibs on each of those. That really the hose faucet piece of it actually becomes very consequential as well. And so between Beehive and ET Water, we cover what we like to say is faucet, residential hose faucet to farm, faucet to farm, because all of those applications represent opportunity for us to use technology to use water in a more beneficial manner.
Yeah, and I got to tell you, sir, before I really took a hard look at a Beehive and all the technology you are offering with that product at that price point, I was really blown away. As far as what the consumers get with that product and the price they pay, boy, I think it's a device that every resident should have in the U.S. on their own, well, worldwide, or any place they're concerned about water. Yeah. But the next thing I wanted to ask you about, right, we're looking at this slide of Enterprise Utah, Center Pivot. There's a big battle between ag and residential water use or city water use. And if you ask me, I think that there seems to be more pressure on cities to produce water than there is on agricultural operations. I just wonder what you think about that. What your ideas are around that.
That's a super question. And if I may, just before I answer it, I would highlight that the price point certainly is affordable for today's technology, but really shout out to the water conserving districts, to the states, to counties and cities for providing substantial subsidies at all levels for those devices, those smart devices, which really has encouraged adoption. We're in the millions of connected devices at this point, and certainly the not the support, but really the driving force of the agencies and the states and local water districts have been super impactful, and so appreciation there.
And I just want to interrupt here and just say, I'm so glad you brought that up, right? Because, smart controller, a couple $100, expect a reduction in water use, 25 to 50%. At the same time, a city might be offering $4 or $5 a square foot to take out turf, a couple $100,000 cost, and maybe the same amount of water savings, maybe less. So I really appreciate the technology being used to save water, because it's really done at a much lower cost.
And now on to your question about, should we call it the water wars, and who should save? And sometimes I'll hear, why should I save on my residential watering, or why should I cut back when ag's the big user? And certainly, the pivot that we're looking at on the screen, that one happens to have just a phenomenal, it's on a just great aquifer. They're measuring it super carefully, which is why the state was so willing to do that that negotiation with regard to the usage. But that's using that one happens to be 1,000 gallons per minute, pivot. So if you think of that on a daily basis, you're at 1.4 million gallons, and then you spread that across the operation, and that's how you get to your that's significant in terms of acre feet, right? That's the big measurement of water. And so people say, well, shouldn't they be cutting back? And the good news is, well, I'll tell you, there are places where proactively they are realizing that if they don't, that they will then be the tail that's getting wagged in the equation. I think the wars are in part, or the water conflict across, and let's say it's not just ag and M&I. M&I is municipal and industrial. Then there's ag within M&I. There's domestic and public supply, self-supplied, and so forth. So there are all these categories of it. But Richard, you at the beginning said something super important. Wherever it is that you are, so speaking to just all of us here on the call today, do you understand what the source is of your water for culinary, your drinking water, and for irrigation? Many places that's the same. Where I live, it happens to be two different sources of water. My culinary water is groundwater, so it's pumped, and it's at a higher elevation, so it's pressurized, but has to be cleaned. And then my irrigation water is lightly filtered, but it's surface water. And obviously my irrigation water has a direct tie to the Great Salt Lake, because that water, if I were not to use it, would eventually get to the wetlands, and then from the wetlands, there's a transition out to the Great Salt Lake. So, but on my culinary water, that's an aquifer that I have a different consideration for. First, it's not worth wasting. If I were doing my outdoor watering with culinary water, I'd be thinking, well, that water still has to be treated, right? There's all the energy, the filtration. In some cases, there's chemicals that have to be injected to get a water, so the water, so that it's culinary, drinkable water, and then that wasting it on an outdoor watering application is just a double misfortune. It's not only redrawing down an aquifer, and you should know, how does your aquifer recharge? Is it a fast charging recharging aquifer, or is it a slow recharge aquifer? But the double part of it is that you're drawing it down, but then you're also using all of the resources to be able to then treat that water. So there's lots that you have to understand about it, and part of the reason why we're doing these that's why I wanted to be on this with you, Richard, is that I hope that we are changing the way people think about water. We like to say, Richard, that we're changing the way the world waters. And the reason that we're doing these things is so that people think more about sources and uses of water, and that makes conservation, I think, much more of a natural thing. In the abstract, it sounds as if somebody, when they say water conservation, is trying to take something away. To a farmer, it almost always just immediately translates into they're coming after my water. And there's a joke, right? It's a half joke among farmers, is that they're coming, for your water. Just make sure the last crop you plant is houses. Um, and I think that with the water wars, my real feeling on it is that we're actually doing a lot by having these conversations to help people understand that it's domestic, it's industrial, it is wildlife management areas. Some people probably don't realize that they have that for those ducks to have somewhere to to nest, and for migratory waterfowl to transition through north and south, they need the water. And then the question of saying, what about industry? And it's certainly where I am, it's used in applications for mineral extraction. But that big technology change. So we're talking about specifically, Richard, I think our focus is being more on irrigation and what we're talking about today. But the other transformation that I'm seeing in technology application to water is in what I'll call is big water. And that's when you talk about an entire basin, an entire watershed, and the combination of watersheds, where the technology is used to actually manage, to measure supply and demand, and measure it on a more proactive basis to avoid the tragedy of the commons. And today there's a tendency, what I observe is that you've got information in lots of different areas being provided not synchronously, in a really timely way, and then put together in a way where we can say, okay, we need to make these adjustments to appropriations in this time frame in order to balance supply and demand, and recognizing that it's not municipal versus industrial versus wildlife versus which today we get that conflict, and it's really an unhealthy tragedy of the commons kind of thing, where it's like, well, I'm not doing my part until the big water user does theirs. And I think we have to just realize that everyone's got to be in on this together, and understanding your water source will help you understand that in most cases, you're not competing with ag for your M&I water. Your tragedy of the commons will result from perhaps the same, let's say it's a climate-driven cause, could be the same cause, but it's very likely that you're on a different, the hydraulics that are affecting your supply are different than what are affecting farm.
Yeah, I certainly appreciate that too, that we do hear often, and I've used it too, right? I'm not going to do something until somebody else does. And that's really just the excuse. You've got to take the action now, is what I think. We got a few great questions coming in, Stuart, that I want to be sure we touch on. And one's, right now for desal, we've got desal here in San Diego where I live, but desal water today is actually at a higher cost than normal supplies of water. But look, everybody expects that to change over the next few years. I know we're getting another 20% increase in the cost of water in San Diego after 35% over the last 5 years. So we know it's getting more expensive. But we think maybe potentially one of our viewers thinks that desal is going to get less expensive as the years go on. Is desal a solution that we can look forward to?
Yeah, absolutely. But I think it falls exactly into the category of my description of my culinary water, right? Is that we are expending resources, therefore we should use the water in a smart way. And certainly if we had, if we had representatives from the EPA and California Energy Commission, I would certainly, advocate for making sure that we have a discussion where we say, how do we use water in the right quantity? In other words, Richard, I think you and I both look at this and say, will you tell me how much water conservation, if we just say use less, obviously the goal isn't, I doubt any water conservancy district or any utility has a mission that says our goal is to eliminate the need for our services. That water conservation is not a goal of zero. What I would say to EPA and CEC and others who are driving the direction of the technology, which are selected, which ultimately get the subsidies put against them. I very much emphasize that it's about how much water do we have available, and then how do we apply that in the smartest ways? Meaning that we apply just the amount that the area that we're needing requires, right? And that's where you then say, okay, it's the timing of it, with then the quantity, the precision of what we apply it to, and then selecting a plant palette, or a crop that makes sense for what's available. And then that's where the technology is really cool, is we can then, using, combination of weather-based data and soil moisture data, then make very smart decisions about the timing of that available amount of water to then achieve the intended result. And so my approach to it would be very much to say, well, you tell me how much water you have, and then I'll tell you the best way, to apply it. Above that, of course, being the question of, the rationale for why you're doing it, which is why I say the scoping of it, meaning that we plant a particular crop for a reason. We plant a specific ornamental landscape and the palette within it for a specific reason. But then tell me how much water there is to apply to that, and we can bring that in super, super close with today's technology. So a little different way of thinking about it, but we are there with the technology, where if we had that target number, we could actually apply that very efficiently over the year.
Yeah, so I think that what you just touched on is really important, because again, it's that the timing. How long do I water? And certainly it's different depending on the root zone of the root depth of the plant, what type of soil you're watering. And I think this is where it gets challenging to a lot of gardeners, residential homeowners, even commercial property managers, and some landscapers. So it's neat that we have the technology to figure that out, because we so often hear the term, you've got to water infrequently for a long time. And if you're watering down to 18, 24 inches and you've got a 6-inch root zone, you've been there, right? You've seen this.
Yeah, we've had breakfast conversation with our friend Dr. Kelly Cope on this, very, very, very subject of sort of the simple things that we use, the axioms, which is water deep and infrequently. In fact, I think didn't we include a graphic here in the next slide, maybe, or it's previous one? I think we skipped over it, but it's like, watering past the root zone, unless there's a strategy for plant development for a very specific crop in a very specific situation, is not beneficial. And so, if you take something like Kentucky bluegrass, which, I think as we talked to Kelly, sort of her reference is 5-inch root zone on that. Deep and infrequently is an easy axiom to say, but not necessarily a good practice. And so our technology today, allows us to just get super, super precise in how long we run to avoid runoff, and then to ensure that we don't do deep percolation where we leach nitrogen and the fertilizer, they'll move through the soil, right? That we can make sure that it stays as much as possible in the root zone.
Yeah, no, and I always think about ourselves too, even like with hunger. If somebody would feed me about halfway to where I was hungry, I'd be much more pleasant, to be around all day, versus when we get hangry, because we just don't perform as well when we're lacking water or food. Another person's asking a question here, right? It is hot all over the United States, I think, this week, especially in the West. We're getting over 130, and in the deserts in California. I think you guys in Salt Lake are getting over 100 pretty consistently now. Do people put two and two together and say, gee, when it's hot like this, we're going to use more water, so we have to conserve more? Or do they just like, it's hot, I got to get in the air conditioner?
Yeah, it's actually super, super complicated, because, and I saw a great post, and if you're on today, I apologize. I don't remember that you were the poster of it, but it just sort of said, look, temperature is not the primary driver. And so we look at temps, and we think that that dictates all of watering. It's certainly an important factor. I mean, if we just look at the equation that we use from to get to reference evapotranspiration, right? Plant water use for a reference crop. You've got about a 10% change into average temp gives about a 5%, 5.5% change in then your ET. You've then got humidity or vapor pressure differential. 10% there gives you about 1%. The solar radiation, so that short wave radiation, 10% gives you about 4%. The interesting thing is that a 10% increase in wind gives about a 3% increase. But think about wind variability, and then recognizing the knock-on effect to wind and humidity. And sorry to get, if this is technical, I apologize, but it's just to say wind is a big deal, because if you're getting a 3% increase for a 10% change in wind, think of what a change of 3 miles per hour to 9 miles per hour in wind does. So if we're talking about Tucson, which the post was, and they were just saying, well, in a muggy July, you could actually see, when monsoon sets in, I say muggy, but relative for Tucson, when monsoon sets in, you can see higher temps than June, but actually the point was you could see lower ET because your humidity helps offset that. But the real wild card then is wind. Yeah. And how many of us can actually figure that one out? And that's where the smart technology comes in, is that the smart technology is taking all of these variables. And I will just tell you, on a very reliable basis, I am a super loyal user of smart technology, and specifically, Penman Monteith. And I will tell you, it works really, really well. And I could never, as good as I am and all the certifications I have, I could never beat, I'll just say, I never beat Beehive. It is at this point, way smarter than I am. And the variables are just too complex. And that wind factor is just an absolute wild card. I just emphasize that is the temps are high, and we talk about that a lot. But wow, watch out for the windy conditions.
Yeah, no kidding. And when you said that, right, 3 to 9, I'm reaching for my calculator trying to figure out the percentage.
Huge.
And yeah, and it's not, it's not that we can't do the calculation. We can, right? It takes some math skill, but not, higher than high school math. But it's the time to actually collect all the data and do the calculation and then download a schedule. That's really where the hangup is.
Yeah. Now, you could ask too, do I believe more in weather-based irrigation control or soil moisture? I will just say we certainly have sold both, and both work very well. Yeah. There's differences in how they're installed. We work super hard to make the installation and the usage process as understandable as possible. But ultimately, every site is going to be a little bit unique. And so the question is, specifically from an app standpoint, is the adjustability in there to allow for incremental, occasional, because you got to allow time for things to, adjust and normalize. But is the adjustment capability in there? Because for both soil moisture based and weather based smart irrigation control, there is some calibration that will make it work super well in the specific site.
Yeah, and I think too, and I've done some very very tough comparisons of soil moisture sensors and ET. And what I'm finding is that the ET data that we get now from the different weather companies that are supplying this information using Doppler, using other radar and local weather stations, the accuracy is really hyper accurate. And boy, as far as installation goes, that's a pretty easy way to go.
Yeah, I know. I absolutely agree with that.
Yeah. So, well, listen, Stuart, I was so excited that you would come on today and talk about conservation. And I knew it would be interesting and exciting, and you did not disappoint today. I thought this was a really interesting and great way to start the new Water Connections webinar series, because you really helped us see big picture wise what we need to do going forward. So do you have any last thoughts for our viewers and listeners today as to what you'd like to see them do, actions to take in the coming weeks and months?
My just last thought, it would be to say, please, let's all join together in advocating and getting the message out for smarter timing of irrigation. It is a very, very high percentage. It's 70% of water consumption. Let's time it well. Let's use really precise equipment, and then let's help users choose the best crops. We call that, right, Richard, changing the way the world waters. It's in the it's in the slide. We believe it, we practice it, and let's all join together. There's good technology out there. Certainly, we're not the only. We don't want to be the only ones in this. We want to be changing the way the world waters together. So I hope we can just all pull together on this. We really can make a difference. And then as that big technology comes over the umbrella of being able to help us manage supply and demand closer, so that we say, how much water is there available on a sustainable, avoid the tragedy of commons basis. It's really exciting for where this is going, and let's help people get on the bandwagon. And I encourage everyone to watch Brad Wardle as he joins you in the upcoming Water Connections, because he is going to get into some just really exciting ways that the technology is actually used. I am a lot of theory. Brad will bring the real way that it's used in super exciting ways. And so I just would encourage everyone to tune in for that webinar. I think it's going to be super exciting. And Richard, thank you for inviting me.
Yeah, you bet. Thanks again, Stuart. And thank you for reminding us about Brad. Next Wednesday, noon Pacific, 1 o'clock Mountain. He's going to be talking a lot about do we really save water by having features in our smart controllers that shut down when it rains and knows when to start back up after the rain, and more importantly, work that rain into your irrigation calculation. So it should be really interesting. I want to thank everybody for joining us today. Really appreciate that. Hope you'll come back next week and see Brad. And I know how busy everybody is in this time of the year. So we really appreciate your time. If you've got some suggestions or additional questions about today, please reach out to me. You all have my email address, and let's talk about it. So again, thanks very much. Appreciate it. And for those of you not able to watch live, we'll be sending the copy of this webinar out to everyone, as well as reposting the audio wherever you listen to your favorite podcast. It's always very inspiring to me to know that people are out there working and educating at the same time. And I just love it when people are listening to our podcast. So check us out there too if you want. Stuart, thanks again. Really appreciate it.
Thank you.